Alright, so in this video we're going to be focusing on this, which is translations. But just to get comfortable with some of our vocab, our overall term is transformation. So the different types of transformations we're going to look at is translations, rotations, and reflections. Like I said, all of those are going to be called transformations. So just so we can get the difference between them. But from a broad term, what a transformation is, so what we're going to look at is something that we've already kind of looked at that with dilation. We're going to look at a specific kind of one. Some stuff that we should already be familiar with are these two terms right here, image and pre-image. Of course, your pre-image comes first. That is your old. And then your image is going to be whatever happens after we have done our transformation to it. So these are two terms that we should be very familiar with. If you remember with our pre-image, we just have regular letters. So if I had triangle ABC, my image would be A prime, B prime, and C prime. We'll talk a little bit more about that. So important to know the difference between those, being able to recognize those with the primes. What we're going to be focusing in on is going to be this, which is congruence transformation. So when we looked at a dilation, we can't call a dilation a congruence transformation because in a congruence transformation, the new image is congruent to the pre-image. The word congruent means same. So it has to have the same shape and the same size. And the same size is what sets it apart from a dilation. When we have a dilation, of course, it changes the size. It either gets bigger or smaller. But these kinds of transformations that we're going to look at is not the case. Like with the translation, with the rotation and reflection, it's going to keep its same size and shape. It's just going to move into a new location. So there's your broad term right there. Just a quick overview on transformations. Let's look at translation specifically. So every single point in your figure, so I'm looking right here, is going to move the same distance in the same direction. So basically what happens, we're going to have a shape. So let's take a triangle. We're going to take that triangle, basically slide it or move it around on a coordinate plane. So that's called a translation. We're going to use prime notation, and again, that's something that we should be familiar with as it is right here. So that's going to come back again like we saw in dilations. So if I say point P, we can read that as point P prime as well. Another term right here is maps or moves. So we can say that an image or a point maps with each other. And then this little thing right here is also super important. This is your transformation notation. So we have our X and Y, and this is how much it's moving, and we're going to scroll down and see the rest of that, but this notation is super important. Okay, so like I said, we're going to look at translations right here. So we've already kind of talked about our vocabulary, but this part right here, which is our notation, is super important. Our X plus A just means how much distance is going to be true. Our X is going to be moving horizontally, so of course horizontally will be left to right. And then B is talking about vertically, that is going to be our Y, so that is going to be up and down. So let's take a look at example 1. So we have a coordinate, or we have a triangle right here that it wants us to graph using those vertexes, so I'll do that really quickly. Okay, so we have a triangle right there, kind of looks like a nice Doritos chip there. So we're going to take this triangle and we're going to apply this translation to it. So basically what's going to happen, you're going to have your pre-image, and then we're going to have our image. So our pre-image coordinates, we do this in different colors so we can kind of differentiate. We have P, Q, and R. So we're going to take all of our original coordinates, and what we're basically going to do is plug them in to our little notation right here, a little system here, and then add 4 to our X and subtract 5 from our Y. And then after we plug those in, what comes out is going to be all of our primes. So Q prime, R prime, and S prime. So starting with Q, I got negative 4, 2. So I'm going to plug basically negative 4 and 2 in right here. So negative 4 plus 4 is going to give me 0. 2 minus 5 is going to give me negative 3. So my Q prime is going to be that coordinate. So let me erase this really quick. That's really all that we have to do. If you can add and subtract, then this should be a very easy thing to do, where you just take your coordinates, plug it into whatever information they give you, and then you just kind of spit out an outcome. So when I look at R, I got 3, 0. So that 3 is going to go here, 0 is going to go here. So 3 plus 4 is 7. 0 minus 5 is negative 5. And then I'm going to do the same thing for my last coordinate, which is S. So to get S prime, I'm going to plug the 2 in, plug the 6 in. So I'm going to get 6, 1, and that is going to be my S prime. So let me graph those really quickly. And there is our new shape. So if we look at it, I didn't kind of connect the lines that well, but if you notice, our triangle didn't move at all, or its shape, didn't change at all, not like a dilation. I just took it over and slid it over. Another way to look at these, or to do these problems, so if I graph these originally, here is my 4 right here, there's my -5. So if I think about, if I have an x coordinate, I'm going to be talking about going left and right, just like the x-axis. So if I add 4 to an x coordinate, I need to think that, oh, I'm probably going to go to the right. And then when I look at my y, if I'm subtracting 5 from my y would go up and down. So if it's subtracting 5, that's more than likely going to go down. So what I'm getting at here is if I look at S, let me do a quick thing and add my primes onto these. Should have done that. So that lets me know where those were my image coordinates. But if I look at my S right here, if I go x plus 4, that means that my x coordinate is going to go 4 spots over, so right there. And then y minus 5, so I'm going to drop down 5. If I count down to 5, if I notice, I'm going to get at that point right there. So that's another way that you can do these problems. Of course, plugging in is going to work, but if you can kind of mentally visualize going over left to right, up and down, knowing what the signs and the numbers mean, that's another way that you can solve these problems as well. Okay, so now this time in this example, they already give us our image and our pre-image, and we have to go and find the translation rule. So this is what I'm going to want you to try this one on your own, and then have you pause, work it, and then come back and check answer that I got. One thing that's super important with these is writing it in that correct notation. So we need to go parentheses x comma y, draw our arrow, and then I'm going to do x, how much that moves over, y, how much that moves over. So make sure we have it in our correct notation right here. So like I said, I'm going to pause the video. I want you to go and try this one on your own, and then check and see if you have the same answer as I do. Okay, so this is the answer that I got, x minus 4, y plus 1. So with this kind of problem, it's very important to identify which one is your pre and which one is your image. Obviously, my pre-image is going to be in this blue triangle, ABC, because I don't see any primes on it. And then with the primes, that is going to be our image. So I started right here at this triangle and then went over to this one. So lots of ways that you can do this, but if you could just kind of look at it, pick a coordinate right here. So if I choose A, I need to count how much this goes over. 1, 2, 3, 4. So that moved over 4 spots, and that is talking about my x. Because I'm going to the left, that means it's going to be a negative. And then when I look at my y, I just went up 1, and because I went up, that means it has to be a positive. So anytime we have a problem like that, we have to do a translation rule. Remember, our notation is super important, and this is the process to go and solve a problem like this. Next thing that we're going to look at is our composition of transformations. So that's going to be example 3 right there, but our composition right there, that just means we're going to have 2 or more transformations that are combined into a single transformation. So just something to keep in mind as we're going to go and take a look at example 3. Okay, so like I said, with our composition, that means we're going to have 2 or more transformations. And when we look at example 3, we should see that we have 2 translation rules. There's number 1, there's number 2 there. So on this graph, we only have 2 endpoints. We're just going to have a line. And what we're going to do is take this line and go through 2 translations. So like we saw in the previous example, example 1, we only had 1 transformation. We just took our coordinates, plugged it into our new ones, or through our rule, got our new ones, graphed it, moved on with our life. That's not going to be the case with this one. We're going to have to go through and do 2 of them. So the process of this, we need to graph our originals really quick. So I got 8, 5, so that's going to be right here. So here is R. And then I got -6 up to 8, so it's going to be right there. So here is my original coordinate. So I'm going to take these original coordinates and I'm going to plug it in to that translation there. So when I look at R, plug it in. So I got -8 plus 5, that is going to be -3. And then I'm going to have 5 minus 2 right there, and that is going to be 3. So my R prime is going to be, let me do this in a different color. My R prime is going to be our coordinate right here, -3, 3. And I'm going to go do a similar thing with S. I'm going to take my S coordinate here at -6, 8, run it through. So -6 minus, -6 right here with our +5. That is going to give me a -1. And then do the same thing with 8 and get 6. That's going to be my prime right there. So now let's go and graph this. So I got 3, 3, so that's going to be, -3, 3. That's going to be right there. That is going to be my R prime. And then S is over here at 1 up to 6. So again, if we kind of look at it, I went over to the right 5, x plus 5, then drop down 2 with my y. So this is where things can get a little complicated. What we're going to do now, we're going to take this R prime and this S prime, so these coordinates that I have right here in green, I'm going to plug those in to that second translation. So that first translation takes me over to get these original coordinates. So this first one takes me right here. Now that I have those, plug that in for my green, I'm going to get, let's do this in purple. I'm going to take those R prime coordinates and plug it in to this second transformation rule. So when I go and do that, I got -3, plugging that into that -4. That's going to give me -7. That +3 is going to give me a 1. So I'm taking my R prime, and if you notice, there's 2 primes here because I'm doing a second transformation to it. So how many other transformations that we do to this is going to add another prime on there. So that's going to be my R prime. You can do the same thing with my original S prime and get S prime prime, or double prime. So that's going to give me -5, because -1 minus 4 is -5. 6 minus 2 right there is going to be 4. So this is going to be my new coordinates. So let me graph those. So I got -7 right here up to 1. This is going to be R prime prime, and then S is going to be right there. That's going to be S double prime. So that is how that transformation looks. Usually what we're going to have, though, is different kinds of transformation. So we may do a translation and then a reflection or stuff like that. But this is just a nice example of our composition.